Today I wanted to make a quick video discussing the ideal gas law. So this gas law is really important to chemistry as it discusses pressure, volume, amount, and temperature. So just like the other gas laws that we were doing in class, this one does something that they don't do. It takes into account the amount of gas. So that could be really important for when you're filling your car tires or pumping up a basketball. If you're adding gas, you're changing the pressure, the volume, and even sometimes the temperature. So math for this equation is really similar to the other problems, but you need to be really careful with the units. So when you have pressure, make sure it's in atmospheres, volume needs to be in liters, amount has to be in moles, temperature has to be in Kelvin. Now the other thing to mention is there's a constant. So R does not change. So whenever you're using PV equals nRT, that's our R value. So we will use that, plug it in for R, and then solve for whatever variable we don't know. So let's try a sample. Okay, so in this problem, it says, what is the pressure? So I'm looking for P, so P equals question mark, in atmospheres exerted by a 0.500 mole sample, so that's N, 0.500 moles, of nitrogen gas. Sometimes that's important, especially if I'm given grams and asked for moles and I need to convert. In a 10-liter container at a temperature of 298 Kelvin. Okay, so we still need our R value, which is always 0.0821 liter atmospheres per mole Kelvin. Now I want to make sure my units are okay. So I was given liters in my R, so I should have liters as my volume right there. Atmospheres, well, my pressure is going to come out in atmospheres, so that's okay. Moles, moles, Kelvin, Kelvin. So I know I have all the correct units for this problem. So now I'm going to use PV equals nRT for the solve. And I need to solve for P, so I'm going to divide both sides by V, so V cancels. So my equation is P equals nRT over V. So N is 0.500 moles. R is 0.0821 liter atmospheres per mole Kelvin. And also on top there is the temperature, which is 298 Kelvin. All of that is over my volume, which is 10.0 liters. So liters would cancel, Kelvins would cancel, moles would cancel. I'm left in atmospheres. So I'm going to put this in my calculator, and it's 0.5 times 0.0821 times 0.0821 times 298, all divided by 10. And I get an answer of 1.22 atmospheres. So let's try one that's a little harder. Okay, so for this problem, it says, what mass of chlorine gas? So that it's kind of N. So I know N is in moles, but N could also, if I find moles, be converted to grams. So if it ever asks for mass, I'm looking for N. Is contained in a 10 liter, so volume is 10.0 liters at a temperature of 27 degrees Celsius and a pressure of 2,660 millimeters of mercury. So I still need R, which is 0.0821 liter atmospheres per mole Kelvin. And now let's check our units with that R value. So I was given liters, and I still have liters there. Atmospheres, I have millimeters of mercury. So before I do anything else, I have to convert it. So I'm going to drop millimeters of mercury, and I'm going to go to atmospheres. That is a 1 and then 760. So that number should be 3.50 atmospheres. Okay, so now my atmospheres are good. So now moles, well, that's what N will solve out in, so we'll just hang on to that. And then Kelvin, I still have to change that temperature to Kelvin. So 27 plus 273 is 300. So 300 decimal point Kelvin. Okay, so I'm using PV equals nRT again. And this time I'm solving for N, so I need to divide both sides by RT so that they cancel. So my new equation will be N equals PV over RT. So I'm going to do that right down there. So N equals pressure, which is 3.50 atmospheres, times V, which is 10.0 liters, all over R, which is 0.0821 liter atmospheres per mole Kelvin, and my temperature, which is 300 Kelvin. Now, all of that equals 1.42. Now, a lot of people get confused here, so let's cancel our units to find out what unit that's in. So atmospheres cancel, Kelvins cancel, liters cancel, so I'm left in moles. So that's 1.42 moles of chlorine gas, and that's not what it asked for. It asked for mass of chlorine gas, so I still have one more step. So I need to take that 1.42 moles of chlorine and I have to convert it. So I have to drop moles of chlorine and go to grams of chlorine. That's a 1 and 70.90 from my periodic table. Moles of chlorine cancel, and I get 101 grams of chlorine gas. And I rounded to 3 sig figs because that's all I was given from the beginning problem.